Okay, so let's get started with chapter 8. We're going to start by talking about inverse trig functions. And the reason why we need to talk about inverse functions is because we're really going to start solving equations in this chapter. And you have to know how to find the inverse of things to solve an equation. For example, x squared, right? How do you solve an equation with an x squared in it? Well, you factor it, of course, but you can also employ the square root property. And the reason the square root property works is because the square root and the square are inverses of each other. Inverse functions under the operation of composition, where you compose one function of the other, undo each other. The range of the function is the domain of that function's inverse, and vice versa. So the domain of a function is the range of that function's inverse. So let's check out this quick little example here. If the domain of f of x is -5 and 7, between -5 and 7 endpoints included, and the range is between 0 and 100, find the domain and range of f inverse. So because of the inverse nature here, f inverse domain is the range of the original function, so 0 to 100, and the range of f inverse is the -5 to 7. They flip-flop, and that's going to become important. That seems like a detail, like whatever, but that detail is extremely important as we move forward. So I just want to remind you how to find inverse functions. I used to love to find inverse functions because it's kind of like taking a function and turning it inside out, which I think is kind of interesting. Anyway, let's take a look here and work this one real quick. I have the steps to finding the inverse here, and you might have learned it a little bit different way, but the first step in finding the inverse for me is replacing f of x with the variable y. Of course, they are the same, and then swapping those variables. So I'm going to do both steps here. So I'm going to say x is equal to y plus 2 cubed over 6. Oops. That was a -1 in the numerator. Okay, so I just flipped the x and the y, and now what we're going to do is we're going to solve for y. If you have a hard time solving for a variable on the right-hand side of the equation, because sometimes students do have trouble with that, you know you can always flip it around and then work there from left to right. Okay, so I'm just going to use all the algebra tricks that we know. First, I'm going to multiply both sides by 6, so I get 6x is equal to y plus 2 cubed minus 1. Remember, we can't really solve anything if it's got a whole bunch of fractions in it, so we need to get rid of the fraction first. And then addition and subtraction moves first. You guys know how to do this. So then we have 6x plus 1 is equal to y plus 2 cubed. Now, what undoes a cube is its inverse. And the inverse of a cube is the cube root remember this little trick here, the index of the radicand will cancel out the exponent here. And then usually at this point is when I flip the sides here. So I have y plus 2 is equal to the cube root of 6x plus 1. Bringing the 2 over, y is equal to the cube root of 6x plus 1 minus 2. And then finally, the last step, which is the step a lot of students skip, but it's super important because these two functions are related to each other, that you denote it so that we know that these two functions are related to each other. So the final step here would be f inverse of x is equal to the cube root of 6x plus 1 minus 2. Now, we could check to see if these guys were inverses of each other by composing the functions. And so what that means is f composed of f inverse, those undo each other and you're just left with that variable, and it works both directions. Now, for them to actually be inverses, if we were testing if these guys were inverses, you would have to go both directions to assure yourself. I won't be asking you to determine if something is an inverse of another, but it's important for you to understand all of these characteristics about a very important concept here in algebra. Now let's talk specifically. Excuse me, I'm getting a little stuffy nose here. The inverse sine function. So let's look at the definition. The definition of the inverse sine function is y is equal to sine inverse of x if and only if, and anytime this is just shorthand, if and only if, okay? Oh, I don't know why I wrote two F's there other than, yeah, anyway. If and only if x is equal to sine of y, where the domain is held between -1 and 1, which happens to be the range of sine here, right? That we've learned before. And the range occurs in between -pi/2 and pi/2. In other words, in quadrants 1 and quadrants 4. Okay, and that means here in quadrants 1 and quadrants 4. So all the solutions for the inverse sine function have to be from quadrant 1 and quadrant 4. Okay? Now, this notation is kind of weird. It's sine to the -1 of x, and it is that inverse notation. It does not mean, let's make sure that you're very, very clear, sine inverse of x is not equal to 1 over sine of x, right? Because that's called cosecant. So this is not true. So the notation is extremely important, and you see that this is not true. The notation can also be written as sine inverse of x, and it can also be written as arc sine of x. These mean the exact same things, and it really is just, this is a more modern way of doing it. This is what we used to do with the arc sine because the typesetting of books. Now, to solve and find the value of the sine inverse function, you must think for what value of sine gives you the argument of arc sine. Okay, so for what value of sine gives that argument? The solution of an inverse trig function is always an angle. It is always an angle. It's always an angle. Sorry, I had a phone call and I got distracted. Now let me see if I can't get back into the game. Okay, let's move on. Because of the repetitive and cyclic nature of trig functions, we focus on the range whenever we're finding the answer. Excuse me. Okay, let me try to do this. So let's look at finding the exact value here. So arc sine of 1. What we're really asking is for what value, for what angle theta is sine of theta equal to 1? That's our question here. Okay, so I threw a table over here. So let's take a look. Well, sine of theta is equal to 1 at pi over 2. And remember, when we're dealing with arc sine, the answer has to be between negative pi over 2 and pi over 2. In other words, it has to be in quadrants 1 and quadrant 4. Those are the two quadrants that the answer's in. If you work it out and you get an answer that is not in that particular quadrant, then you're going to have to do some work to get it back to that quadrant. So back to this question, for what angle theta is sine of theta equal to 1? Well, that is theta is equal to pi over 2, because sine of pi over 2 is equal to 1. Let's take a look at this next one here. Arc sine of negative 1/2. Well, negative 1/2, so up here where it said arc sine of 1, well, we know arc sine of 1, that's going to have to be in quadrant 1 because that's the positive answer. When we're talking about this and we're looking at these quadrants, quadrant 1 is going to give all the positive answers, and quadrant 4 is going to give all the negative answers. Okay, so that guy is in quadrant 1. Let's look at the next one. This is arc sine of negative 1/2. Well, that one is going to be quadrant 4. Okay, so what we want to know here is for what angle theta is sine of theta. And I'm not going to go so far as to get all in the weeds with the negative 1/2. Let's just figure out 1/2. Let's find that out first. So we know that theta, for it to equal 1/2, is the angle is pi over 6, but pi over 6 is in quadrant 1. We need the quadrant 3 answer. I mean, not quadrant 3. My bad, y'all. Super sorry. We need the quadrant 4 answer. Right? And we can do that real quick. And I'm just going to show this here real quick. We're dealing with pi's over 6's. So this is 12 pi over 6, right? And this is 6 pi over 6. And if we need the angle in quadrant 4 would be 11 pi over 6, or what our textbook does is use a negative angle, which would be negative pi over 6. So our quadrant 4 answer, theta, is actually equal to negative pi over 6. Because we're looking in quadrant 4. I would accept the 11 pi over 6. In fact, that's how I typically teach it when I'm not really heavily focused on the online homework and stuff. But same kind of idea. Okay, and then this last one here, let's have this one be a you do. Okay, and I'm going to give about a minute for you to figure this out. Okay, so because of the argument here being a negative number, we're looking for an answer in quadrant 4. So first we find the answer in quadrant 1, and then we adjust, just like we learned how to do in chapter 7. So theta is equal to pi over 4 to give the value of the square root of 2 over 2 when evaluated by the sine function. But pi over 4 is in quadrant 1. We need quadrant 4. So theta is equal to, and in quadrant 4, and I'm just going to do this because I find that I have to do this a lot in class. So I'm just going to keep on doing it in this class. So to get into quadrant 3, that is going to be 7 pi over 4, or what the textbook is going to ask you for is going to be negative pi over 4. But I need you to see these guys as equal because I don't really know what your calculus teacher is going to really want to see from you. For me, I usually avoid the negative angles in calculus. But anyway, okay, let's keep on going. So we did the inverse sine function. Let's look at the inverse cosine function. The definition is almost the same, but you will notice that there's a difference in the range here. So notice y is equal to the arc cosine of x if and only if x is equal to cosine of y, where x is in between -1 and 1. Again, the range for f of x, so the range for cosine. This is range for cosine. And the y here is going to be quadrants 1 and quadrants 2. Okay, so for the cosine, we only care about these two quadrants. And here, the cosine is positive and the cosine is negative. So quadrants 1 and quadrants 2. The notation situation is the same. To solve it is the same. We're going to say for what, and I don't know why I wrote value here. I should write angle of cosine gives you the argument of the arc cosine. So gives you the argument. So let's look at a couple of examples here. Let's find some exact values. So we're going to do it the same way. First, we're going to decide what quadrant our answer is going to be in, and then we'll find that reference angle or the answer, and then we'll find the correct angle in the appropriate quadrant if it's not a reference angle. All right, so let me write up here again that our range is between 0 and pi. So in other words, it's these guys. And this is where it's positive, and this is where it's negative. Okay, so cosine, arc cosine of 1/2, well, that is in quadrant 1 because it is positive. So we can just do it, and what I'm going to ask is what theta gives cosine theta equals to 1/2. I mean, that's basically the question here. And so let's look. Cosine of theta is equal to 1/2 when theta is equal to pi over 3. And this is the answer because it is in quadrant 1. Okay, let's look at the next one here. Arc cosine of 0. Okay, now that is one of those quadrant angles. And the quadrant angles means that it only happens once. Between 0 and pi at pi over 2. Okay, well, we know that from some of the studying that we've been doing on these functions, so theta is equal to pi over 2. No decisions to be made here because that's the only place between 0 and pi that the cosine is equal to 0. Okay? All right, cool. Let's go to the next one here. Here we're looking at the argument of negative square root of 3 over 2. So this is going to be a negative answer. So, and I don't know why I wrote 4. So our answer needs to be in quadrant 2. So we want to know what theta gives cosine theta equals root 3 over 2. And that is pi over 6, but pi over 6 is in quadrant 1. We need quadrant 2. So let's look at that real quick. Let me just draw our little thing here. We've got 6, we're doing to the 6, so that's 12 pi over 6. This is 6 pi over 6. So if we need to be in quadrant 2 here, then theta is equal to 5 pi over 6. If you're still having trouble with figuring this out after the work in chapter 7, I'm really going to suggest that you holler at me. Let's have a quick tutoring session so I can do lots and lots and lots of examples for you to practice until you get it with me kind of helping you. Okay. All right. And so finally, let's let this one be a you do. We'll give you about a minute. Okay, because this has got a negative argument, we're looking for our solution in quadrant 2. We want to know what theta gives cosine theta equal to square root of 2 over 2. So that is theta is equal to pi over 4. But pi over 4 is in quadrant 1. Need quadrant 2. So I'm just going to use this guy again. This is 8 pi over 4, and this would be 4 pi over 4. So to get to quadrant 1, we need to subtract a pi over 4 from that. So theta is equal to 3 pi over 4. Okay? All right. Let's do the arctangent. So arctangent, here's the definition for the arctan. And again, be mindful of some of the things that we've already learned here, which let's read this definition. Y is equal to the arctan of x if and only if x is equal to the tan of y, where x is all real numbers. Remember that this is the range of tangent. And here our range of the arctangent is these two quadrants, quadrant 1 and quadrant 4. So this is the same as sine. Okay. All right, again, the notation's the same. Again, how we figure it out is the same. All of the rest of this information, the same. Let's do some examples. Now, because I see all of these arctans here, I'm going to come over here to my table and I'm going to add the tangent stuff. Okay, so this is 0, and because going from left to right on the tangent function is increasing, then we know that the values are getting bigger here. So if you happen to know some of the values, like you know there's 1, well, of course, square root of 2 over square root of 2 is cool, but then you know that the other two values are the square root of 3 over 3 and square root of 3, but you're not sure which way they go. Well, they go from small to big. Okay, so that took just a second for us to complete up that table, and now we don't have to like do the math as we go along. All right, so the first one here, tan inverse is equal to 0. Oh, let me talk about our quadrants that are in here. So here and here. This is the range, and tan is equal to 0. So what is our question? So for what theta is tan theta equal to 0? Well, tan theta is equal to 0 at 0 and at pi. Pi is outside of the question, so theta is equal to 0. Because 0 is in quadrant 1 and pi is not in the range, right? So we can't use that one. All right, cool. Let's take a look here. Tan inverse or arctan of -1. This is in quadrant 4 because the tangent is negative, right? Quadrant 4, and we want to know what theta is tan theta equal to 1, right? And that happens when theta is equal to pi over 4. But this is in quadrant 1, so we need quadrant 4. So we can say theta is equal to negative pi over 4, and that's going to automatically give us a quadrant 4 answer. But let's go ahead and just look here. Remember that 0 or 2 pi is 8 pi over 4. This is 4 pi over 4, so to go backwards one spot is 7 pi over 4. So it's negative pi over 4 or 7 pi over 4. Those are the same. Okay, let's look at the next one. Arctan of -√3 over 3. This is going to give us an answer in quadrant 4 as well because of that negative in the argument. So we want to know what theta is tan theta equal to √3 over 3. That is when pi over 6. It's when theta is equal to pi over 6, but that's in quadrant 1. We need quadrant 4. So theta is equal to, if this is pi over 6, then this is 12 pi over 6. This is 6 pi over 6. So that means theta is equal to negative pi over 6 or 11 pi over 6. Awesome. Okay, the repetitive nature never ends. Let's give you a you do, and I'll give you about a minute to do that. Okay, here our answer, because it is a positive argument, we're looking for the answer in quadrant 1. So now we can just look over here at our chart here, and we can quickly say that theta is equal to pi over 3. Okay, so let's shift gears just a little bit. Let's take a trig function and find the inverse. So earlier in this lesson, I went over how to find the inverse and the steps to find the inverse. The steps of finding the inverse of a trig function are exactly the same. So first we'll find the inverse, and then we'll work on the domain and range thing. So let's find the inverse. The first step is to replace f of x with y and then swap x and y. So this is going to give me x is equal to 2 sine of y minus 1. Now, we need to solve for y. And remember, we have to move all the addition and subtraction away first. So this is going to give us x plus 1 is equal to 2 sine y. I'm also going to divide both sides by 2. So we get x plus 1 over 2 is equal to the sine of y. Now, we need to get it to just say y, right? So what undoes the sine is sine inverse. So we're going to take the sine inverse of both sides. So I'm going to say arc sine of this side is equal to the arc sine of this side. Let me just stick everything in here. This is x plus 1 over 2, and this is the sine of y. Now we have that lovely thing that happens with inverses where they cancel each other out, and we're left with f inverse of x is equal to the arc sine x plus 1 over 2. So here's our inverse. Now the next thing we're asked to find is the domain of f inverse of x. Now the domain of f inverse of x is the range of f of x. So let's figure out our range of f of x. Now, if we look at our equation here, we have an amplitude of 2. So we'll start off with that. So the amplitude of 2 means that our values are going to go from -2 to 2. Now we also have a shift down of 1. So if I subtract 1 from each of these guys here, I clean this up, then we can see that our range is from -3 to 1. This is the range of f of x, but also the domain of f inverse of x, which is what we were asked to find. So here is our domain of f inverse of x. And now the other thing we're asked to find is the range of f inverse of x. And to do that, we set the argument in this equation. Hold on, my brain just like went left turn, Clyde. Let me just look real quick and make sure I'm not fixing to just tell you something absolutely crazy. I'm not. Okay. It's kind of late. All right. Then I was distracted with a phone call, so I'm not. Okay. So we put it into this equation. It is the I'll show you. Sorry. -1 less than or equal to the argument of f inverse of x that you just found less than or equal to 1. Okay, that's what we do. We tuck that argument in between the range of f of x. All right, and so here we go. We're going to solve this. So we have -1 less than or equal to x plus 1 over 2 less than or equal to 1. And we solve this equation. So the first thing we do is we got to get rid of that denominator. So I'm going to multiply everything through by 2. So that is equal to -2 less than or equal to x plus 1 less than or equal to 2. And then we can subtract -1 from all three sides here. I know you have experience with solving these equations. It's part of the college algebra curriculum. So this is -3 less than or equal to x less than or equal to 1. And so the range of our f inverse of x is this guy. No, what did I do? Ah, shit. Okay. Okay, so y'all, I have not figured out how to edit this, but I just totally did this range completely wrong. Like, completely wrong. Like, I did the way that you can figure out the domain algebraically. So I hope you guys can give me some grace on this. I don't want to have to start recording over. I'm 40 minutes in on this video and we have 3 more slides. I'm not doing it. So we're going to erase that. We're going to pretend like the last 3 minutes didn't happen. Okay. And I'm going to reset right here. All right. So the range of f of x. Remember the range reset it one more time. Let me get a drink. Hold on. I don't want to lose it now. Okay. The range of the inverse function, or the range of arc sine, is the domain of sine. Okay? And we were explicitly given what the domain on the sine function was. So the range is this restriction here. So the range is going to be from -pi/2 to pi/2. Now I know I really screwed the pooch on this one, and I'm really sorry I did. So we'll do another one and it'll be cleaner and I won't stumble, and we'll be all good. So sorry. I wrote this PowerPoint a few days ago too, so I don't really remember. Okay, here we go. Let's do another one. And I would have given this for you to do as a you do, but since I absolutely screwed the pooch on the range on the last one, I feel like I need to give you a very clean example here. So let me try to redeem myself here. Remember, we're all human in this. So first, let's find the inverse. So first I'm going to find f inverse of x, right? And we flip x and y. We replace f of x with y, and then we swap x and y. So we're going to have x is equal to the cosine of y plus 2 plus 1. And now we're going to solve this guy for y. So we have x minus 1 is equal to the cosine of y plus 2. Now this trig function is absolutely isolated, so we can apply the trick. And the trick here is taking the arc cosine of both sides. So the arc cosine of this side is equal to the arc cosine of that side. And this is going to be an x minus 1, and this is going to be the cosine of y plus 2. And we have that beautiful thing happen where these guys cancel each other out. I'm going to rewrite it like this. Y plus 2 is equal to the arc cosine of x minus 1. And then we get to move that 2 over. So I'm even going to skip another step here, and this is going to be the cosine, arc cosine of x minus 1 minus 2. This is our inverse. Now, the domain of the inverse. We can find it two ways. The first way is to depend on the range. So off the range of f of x, or to this equation. -1 less than or equal to f inverse of x argument less than or equal to 1. So either way, we can find this answer both ways, and I'll do this one both ways. Okay, so first off, the first way is finding the range of f of x. So let's remember, we always start the range of sine or cosine as 1 to the -1, and here there is no amplitude, and we have up 1 unit. That's what we've got going on here. So we just got to say +1 and +1 here, and so our range is going to now be 0 to 2. I mean the domain. Well, I'm so close, so let me clear up here. So this is the range of f of x and the domain of f inverse of x. Okay? Those are one and the same. And then we can work it out this other way as well. So we can do it that way, or we can do it this way. -1 less than or equal to the argument is x minus 1 and then we can just solve this equation here by just adding 1 to both sides, and we get 0 less than or equal to x less than or equal to 2, which also gives us the same range. I mean, again, the same range of f of x, domain of f inverse of x. Okay, and then I think the last thing we need to find here is the range of f inverse. And that is going to be what is already given to you, which is the domain of f of x. This is the domain of f of x given here. So the range then is going to be from -2 to pi minus 2. Okay. Let's talk about some other kind of interesting properties. Thank you for letting me get through that. Thank you for sticking with me. Remember that if we were live in a classroom and I started messing up, it would be the same thing. I can't redo it. And human is human. So y'all hang in here. Okay. Let's take a look at the properties of inverse trig functions. So for the functions f of x, f inverse of f of x is equal to x. And we know this because, and I'm just going to do a little example here, but if we have f of x is equal to x squared, and f inverse of x is equal to the square root of x, then f composed of f inverse of x is equal to the first function written down completely, the second function inside. Those guys are going to cancel each other out. As we know, square roots are canceled out by squares, and it is equal to x. So this is something that you already know. This is just kind of like defining that this is true, but it's true only on restricted domains. So here's the list of all the restricted domains. So it's basically the same thing we've already been doing, but I'm wanting to give it to you in a way that you can see it if it's the arc sign of the sign or the sign of the arc sign, because that depends on what it is. So here's the idea. It's always about the inside function here, and so the inside function here is plain old sine, and plain old sine is only defined in quadrants 1 and quadrants 4 when we're dealing with our inverse functions. Now, when we are solving an inverse function with a sine, remember that the only values that are valid for sine, the only outputs for sine without an amplifier or whatever, is the range is from -1 to 1. Just another way of saying this, okay? And I just spelled it out for all three of them. It's just a good reference to come back and look at. So the second one here, this is quadrants 1 and quadrants 2. And we're talking about our range between -1 and 1 here. And then when we deal with tangent, that's the same thing as sine, so that is quadrant 1 and quadrant 4. And here, our domain, remember, is all real numbers. Okay, now, this feels like you've just shown us the same thing we've been seeing. No, so let's check these guys out. Now, you have to be very, very mindful of what the domains are for everything here. So cosine, remember that cosine here has to be quadrants 1 or quadrant 2. Tangent is quadrant 1 or quadrant 4. The cosine, now check these out. These are arcs, right? That's the arc cosine and the arc tan. So those talk about quadrants. The arc sine, that talks also about quadrants. Quadrant 1 and quadrant 4. But if it starts off, notice this guy's not an arc. This is just plain old cosine here. Starts off like that. Well, there we're talking about it's got to be between -1 and 1. Okay, So the first thing to note when you look is you got to decide where these answers lie. And this is where some of the difficulty starts coming in Trig. It's the devil is in the details. These are very little details that don't look like they would matter at all, but they matter very greatly in trigonometry. Okay? So give yourself some grace, practice, ask for some help, do problems outside of your homework so that you get understanding. Pause my videos and work examples alongside me. Go back and rewatch videos trying to work my problems as well. That's where you'll start having those aha moments so that you understand what's going on. Okay, so now this is cloyingly simple looking. Okay? Cloyingly simple. Do not fall for it. But remember, when you have the inverse and the original function together, they do cancel each other out. And we are left with the argument of the inside function. But now you have to be sure this answer is in the range, or is in Q1 or Q2 in this case, because we're dealing with cosine. Well, 4 pi over 5 is 1 click shy of pi, and here, especially since this is over 5 here, so let's just look at it here. If we're dealing with 5s, this is going to be 5 pi over 5. And this is going to be 10 pi over 5. So 4 pi over 5 is definitely in quadrant 2. So be sure that this answer is in quadrant 1 or quadrant 2 because we're dealing with cosine. It is. Check. We're good. Okay. So again, cloyingly easy looking until we get into something that isn't. So let's look at this one. Arctan and tan, they cancel each other out. And that leaves me with negative 4 pi over 5. So we're dealing with the pi over 5s again. And if we were to graph negative 4 pi over 5, it would be over here. And that is in quadrant 3. And we can't have a quadrant 3 answer. We have to have a quadrant 4 answer. And we know we need a quadrant 4 answer because of the negative. Okay, so now we have to lean back on all the things that we learned in chapter 7. So we're in quadrant 4. We need to get in we're in quadrant 3. We need to get it around so we can get a quadrant 4 answer. So the first thing I'm going to do is I'm going to go coterminal. So I'm going to find coterminal. Let me find that coterminal angle by saying negative 4 pi over 5 plus 2 pi. That's equal to negative 4 pi over 5 plus 10 pi over 5. That's going to give me 6 pi over 5. 6 pi over 5 is in quadrant 3, right? So now we find the reference angle. Because we're in quadrant 3, we say theta minus pi to find that. So we have 6 pi over 5 minus pi is going to give us a plain old pi over 5. Now that is quadrant 1. We need quadrant 4. So finally, it's equal to negative, now, could be negative 9, sorry, so close here, so it can be negative pi over 5, right? Or if we didn't want negative angles, if all we wanted was positive angles, that would be 9 pi over 5. Both of these answers are equivalent. That one was convoluted, a lot of little things. None of the steps difficult, but you have to understand, right, where we have to give our answer, and then we have to understand how to move around the circle to get to that answer. Okay, let's look at the next one here, and then I'm going to give the last one as a you do. So this next one here is the cosine of arc cosine of 2.3, and here the answer has to, the range of the arc cosine, so the range of the cosine is -1 to 1. That means that the domain of the arc cosine is -1 to 1. So this is actually no solution because the range of cosine, which is -1 to 1, is the domain of arc cosine, and 2.3 is not in the interval of -1 to 1. Therefore, no solution. All right, and then finally, I'm going to leave you with this you do here. Let you work on that. I'm going to give about a minute. Okay. Well, first, at first inspection, when we cancel these out, we're left with 9 pi over 8. All right. Let's figure out what quadrant 9 pi over 8 is. This is 8 pi over 8. So this would be 16 pi over 8. So it looks like 9 pi over 8 is in quadrant 3. And we need, in this case, a quadrant 1 answer. So find the reference angle. To 9 pi over 8. And we do that the same way we did it up here. So we get to say 9 pi over 8 minus pi is going to give us pi over 8. And so our answer is pi over 8. Okay, so this is what I'm going to tell you, and I know I've said this already once. You've got to practice this. You can't do 2 or 3 of these problems and have it like set in your brain. I probably did not give you enough homework practice for this. So please maybe go through this particular lecture, write down these problems on a clean piece of paper, work through your homework, and then work some more problems from this just to make sure that you understand the concepts, because this is just going to build. This is section 8.1 in chapter 8. So know that this is not the end game. This is just starting to figure out the game. Okay, you guys have a good night.